જ ચાલે છે. ગુડ ઇવનિંગ. Hello. I request all the students to kindly come forward. Our dignitaries are just on the way. We are starting program in 5 minutes. ફરીથી એક વખત રિક્વેસ્ટ કરું છું, પાછળની રોમાં જે બેઠા છે એ થોડાક અહીંયા વચ્ચે અથવા તો આગળ આવી જાય. Faculties and students to occupy front seats. In 5 minutes we are just starting the program. લાઈવ સ્ટ્રીમ શરૂ છે ને? ચાલુ છે? દેવાંશ, લાઈવ સ્ટ્રીમ ચેક કરીને કે મને મેસેજ આવે છે કે નથી આવતું. અને જસ્ટ આપને પણ જણાવી દઉં, આપણે અહીંયા બેઠા છીએ માત્ર આપણે આટલા લોકો જ નથી. દેર આર ઇન ઓલ 33 districts of Gujarat we have all community science centers, so the students are sitting over there also, so it's a parallel broadcasting. Apart from that we have programs in regional science centers, 4 regional science centers, Patan, Bhuj, Bhavnagar and Rajkot. ત્યાં લાઈવ સ્ટ્રીમ નથી પણ ત્યાં અલગથી એક્સપર્ટ્સ છે અને ત્યાંના એક્સપર્ટ્સ એમને સમજાવી રહ્યા છે. એન્ડ ઇટ વિલ બી સિમિલરલી ફોલોડ બાય ધ લાઈવ સ્ટ્રીમિંગ ફ્રોમ સ્વીડન ફોર ધ નોબેલ ઇન્વેસ્ટિચર સેરેમની. તો તમે બધા 33 જિલ્લામાં દેખાઈ પણ રહ્યા છો અત્યારે. તો આઈ રિક્વેસ્ટ જસ્ટ તમને ખબર હોવી જોઈએ કે ધીસ ઇઝ બિંગ ઓર્ગેનાઇઝડ ઇન દેટ વે. થેન્ક યુ. આજના આપણા હેલો, આપણી વચ્ચે ડૉક્ટર સંજય ઠાકર સર, ફોર્મર ઉપસ્થિત છે. સરનું તાળીઓથી સ્વાગત કરીએ આપણે. સર આપણને નોબેલ માર્ગદર્શન આપશે. પછી આપણી વચ્ચે ઉપસ્થિત છે ડૉક્ટર આ માઇક બંધ થઈ જાય છે વારે ઘડી. સર ડીન છે સિટીના. થોડી વારે બંધ થઈ જાય છે. કોઈ હા હા, એક જ મિનિટ બોલાવી લઉં. I request all our dignitaries to please take their seats on the dais. Welcome, sir. Satyati. All our experts and all dignitaries are invited to the dais to take their seats. આપણી વચ્ચે આજે ઉપસ્થિત છે ડૉક્ટર આર.સી. પટેલ સર, ઓનરેબલ વાઇસ ચાન્સેલર IITE, ડૉક્ટર નરોત્તમ સાહુ સર, એડવાઇઝર એન્ડ મેમ્બર સેક્રેટરી ગુજકોસ્ટ, ડૉક્ટર પ્રેરણા શેલત મેમ, ડાયરેક્ટર સેન્ટર ઓફ એજ્યુકેશન IITE, ડૉક્ટર સંજય ઠાકર સર, ફોર્મર પ્રિન્સિપલ શ્રી M.N. શુક્લા કોલેજ ઓફ એજ્યુકેશન, ડૉક્ટર રાકેશ રાવલ સર, ડીન ડિપાર્ટમેન્ટ ઓફ મેડિકલ બાયોટેકનોલોજી, ગુજરાત બાયોટેકનોલોજી યુનિવર્સિટી, ડૉક્ટર અનાક ભૌમિક સર from IIT Gandhinagar, and Dr. Poonam Bhargav ma'am, Principal Scientific Officer from GUJCOST. Please give a huge round of applause for all our dignitaries present on the dais. And as per the custom of IIT, we will be beginning the program with the Institute song.
सदृशं पवित्रं इह विद्यते, नहि ज्ञानेन सदृशं पवित्रं इह विद्यते.
રાષ્ટ્રની ઉજળી આવતી કાલના અમે છીએ ઘડવૈયા,
અંધકારની સામે અડીખમ પ્રકાશના લડવૈયા, તૂટે તિમિર તણાહર બંધન, તૂટે તિમિર તણાહર બંધન.
IIT तुझने वंदन, IIT तुझने वंदन.
પરંપરાને પ્રયોગ કેરું થાય ઉચિત સન્માન,
ઘડવૈયાનું ઘડતર કરતું ઉત્તમ વિદ્યાદાન.
પરંપરાને પ્રયોગ કેરું થાય ઉચિત સન્માન, તુજને કોટી કોટી અભિનંદન, તુજને કોટી કોટી અભિનંદન. IIT
तुझने वंदन.
સુરાશના નિર્માણને સાર્થક કરતું ઉત્તમ શિક્ષણ.
સંસ્કૃતિનું રક્ષણ આધુનિકતાનું આહ્વાન.
સુરાશના નિર્માણને સાર્થક કરતું ઉત્તમ શિક્ષણ. પ્રગટે જ્ઞાન તણા જ્યાં સ્પંદન. પ્રગટે જ્ઞાન તણા જ્યાં સ્પંદન.
IIT
તુજને વંદન.
IIT
તુજને વંદન.
IIT
તુજને વંદન.
IIT
તુજને વંદન.
તેત્રીસે 33 જિલ્લામાં અમારા જે જિલ્લા લોકવિજ્ઞાન કેન્દ્રો છે, કમ્યુનિટી સાયન્સ સેન્ટર્સ, ત્યાં પણ સેંકડોની સંખ્યામાં પાર્ટિસિપન્ટ્સ મોજૂદ છે અત્યારે. તો એવું પણ આપણને અહીંથી યુટ્યુબ લાઈવના માધ્યમથી નિહાળી રહ્યા છે. આપ સર્વેનું પણ હું સ્વાગત કરું છું આ કાર્યક્રમમાં. ભારતીય પરંપરા અનુસાર કોઈપણ કાર્યક્રમની શરૂઆત આપણે જેમ દીપ પ્રાગટ્યથી કરીએ છીએ તે રીતે હું આપણા મંચસ્થ મહાનુભાવોને વિનંતી કરીશ કે તેઓ આગળ આવે અને દીપ પ્રાગટ્ય કરીને કાર્યક્રમને ખુલ્લો મૂકે. થેન્ક યુ. Now I would like to invite Dr. Poonam Bhargav ma'am for a welcome address.
A very good evening. A very good evening to one and all. Respected R.C. Patel sir, respected Sahu sir, our invited dignitaries, Sanjay sir, Dr. Rakesh Rawal, Dr. Anak Bhaumik, Prerna madam, members from IITE, the faculty of IITE, and the students here. It is my immense pleasure to welcome all our distinguished dignitaries as well as the participants here today, as we have gathered here on this special celebration of Nobel Prize Day 2025. Today we'll be honoring the legacy of Alfred Nobel and to acknowledge the transformative scientific achievements for the greatest benefit of humankind. This event is being organized in collaboration with IITE Gandhinagar, and we have been fortunate enough to actually get the support of IITE as and when required, and with full support from the faculty. It is indeed a great pleasure to host programs over here. Today, together we aim to ignite scientific curiosity, and we also inspire our next generation here, who are actually our next innovators and educators. So as we all know that Nobel Prizes actually represent the highest ideals of human intellect, perseverance and creativity. So as today we are going to reflect with the help of our experts on the groundbreaking contributions that has been recognized this year in chemistry, physiology, medicine and physics. So our experts are going to explain the complex Nobel laureates' work in very easy language. With this, I express my heartfelt greetings to all my experts here and all the students, the future educators who have joined us today here. So let us celebrate today the Nobel Prize Day with all enthusiasm, as it is actually for the greatest benefit of humankind. Thank you.
થેન્ક યુ મેમ. હવે મેડમે શબ્દોથી સ્વાગત કર્યું, હવે ફૂલોથી સ્વાગત કરવા માટે this is time for floral welcome. I would like to invite Dr. Nor to present a floral bouquet to our chief guest, Dr. R.C. Patel sir, Vice Chancellor, IIT. I would like to invite Dr. Prerna Shelat ma'am to present a bouquet to Dr. Narottam Sahu sir, advisor, GUJCOST. Next, I would like to invite Dr. Poonam Bhargav ma'am to present a bouquet to Dr. Sanjay Thakur sir. I would like to invite Dr. Paras Uchat sir to present a floral welcome to Dr. Rakesh Rawal sir. Next, I would like to invite Dr. Poonam Bhargav ma'am again to welcome Dr. Anak Bhaumik sir, IIT Gandhinagar, with a bouquet. Thank you. Now I would like to invite Dr. Prerna Shelat ma'am, Director, Center of Education, IIT, to share the opening remark.
Thank you, sir. Good evening to the dignitaries on the dais, Honorable Vice Chancellor Professor R.C. Patel, sir, Dr. Narottam Sahu, sir, Advisor, GUJCOST, Dr. Rakesh Rawal, Dean, Department of Medical Biotechnology, Gujarat Biotechnological University, Dr. Anak Bhaumik, Assistant Professor, IIT Gandhinagar, Dr. Sanjay Thakur, former Principal, Shri M.N. Shukla College of Education, Dr. Paras Uchat, Dr. Poonam Bhargava, faculty from my own institute, IIT, and all the members from GUJCOST, my dear students. In fact, 10th of December, yes, a day to commemorate a novel and a noble person by thought, divergent in thinking. We all know Alfred Nobel. It's the death anniversary that we are celebrating on 10th of December. And he came out with number of wills, finally coming out with a will telling that my property should be given to the ones who do some good work in order to help the humans. And thus, we came out with the Nobel Prize, the first Nobel Prize in the year 1901. That was the 5th death anniversary of Alfred Nobel. And today, in 2025, that is 124th edition of this Nobel Prize ceremony, which we are celebrating. A prestigious award, I would say. And we all know that originally it was in 5 different fields that this prize was being awarded: physics, chemistry, physiology, or medicine, literature, peace. And it was in the year 1968 that economics sciences was added as the 6th category. And it's my pleasure to share that every recipient, the laureate, gets a green gold medal, plated 24 carat, a diploma, and a monetary award. Let me share the monetary award which the winners will be getting this year amounts to more than 10 crore rupees when converted to Indian currency. Look at the thought which came to Nobel, Alfred Nobel, who came out with applauding the individuals who are really working hard and coming out with their invention to help the humankind. Yes, I should really appreciate the very thought of this noble person. And that medal, which is very well projected over here, it has the back and the front side has got the birth and the death year of Alfred Nobel been printed on that, which should be known to all of us. And I would also want you all to know, being a female, I was very much interested to know that how many females, how many women were awarded a Nobel laureate till date. And it is 67 women were being given the Nobel laureate till date, and that amounts to 68 because Madame Curie got it twice. And thus, it's 68 females who have received Nobel laureate. And among them, I am really a proud Indian to say, if the data is wrong, please pardon me, 12 Indians are the ones who are among the Nobel laureates till date. So really proud to have this day been celebrated at my own institution, IIT, and my students witnessing this. I would say I am welcoming you to remember to applaud the laureates, and yes, a day to give you all an inspiration, as my name says, Prerna, so that you all young scientists, may you be in social science, may you be in sciences, take inspiration on this very day. And one fine day, maybe if at all I am alive, I would say yes, my IITians are the ones who are one among this laureate. With this, I welcome you all once again. Thank you.
Thank you, ma'am, for your inspiring speech. Next, I would like to invite our advisor and member secretary, sir, Dr. Narottam Sahu, sir, to say a brief about the Nobel Science. Welcome, sir.
Good evening to everybody. Honorable Vice Chancellor, sir, all our esteemed faculties, Nobel faculties, Dr. Sanjay Thakur, sir, who will be giving the insight of this year's Nobel Prize in Chemistry, Dr. Rakesh Rawal, sir, who is also taking us to the significance of this year's Nobel Prize in Medicine or Physiology, and Dr. Anag Bhaumik, sir, will take us to the quantum age, how these three things are going to be the change maker for the next decades or next century, we can say. In addition to this one, we have all other faculties in physics, chemistry, mathematics. They are also sharing the same thoughts and ideas at our the regional science centers Patan, Bhavnagar, Bhuj, and Rajkot, where we have a dedicated Nobel Prize gallery in this subject. So why we are celebrating this day? Ma'am has already mentioned all the genesis and history or all these things about this thing, fascinating facts. So the journey started. This idea came from us in 2017, where we hosted a galaxy of Nobel laureate at our Science City campus, and that was followed by a 3 month of exhibition set up by the Nobel Foundation. They came from the Stockholm, Sweden, and they are here with us for 3 months. And this program was inaugurated by Honorable PM, and we had a designated hall for that thing, and that hall or that dome is still known as Nobel Dome in Science City. And the way the pathways inside the Science City, where the Nobel laureate, 9 laureate at a time, it was also history. When they were passing through that way, we named that pathway as a Nobel Path. Okay, so whenever you are going to visit this thing, it is not only like that way. First time we also did a very noble come that idea also. Whenever some good things is there, we have trying to get some reprint. Okay, so there also we tried that things. So our secretary that time, so he was giving that idea that when these laureates along with our honorable prime minister, they came into the stage, the dais, and they have to going to open that exhibition. So we have put a board with this plaster of Paris, and everybody was requested to put their fingerprints, this 2 hand palm. So everybody 9 laureate as well, along with the prime minister. So 10 pairs of fingerprints are there. So we took it as a idea to make it convert into an exhibit. So that exhibit is also there. Whenever you are going into the Science City, so that path, Nobel Path, is in front of our admin building, and on the front of that thing we have that plaque where you can match your palm with the Nobel laureate palms or honorable PM or anybody that things. So after that exhibition, when we are designing our new science centers, mini science cities across the other regions, so we thought that this Nobel history, Nobel knowledge, and Nobel ideas are really noble in nature. It's a lots of a fascinating story in inspirations and all these things is struggle, challenge, all these things is there, and finally it comes with a happy ending and a success story, and which all invention or discoveries or the process that takes our lifestyle or our culture, our civilization or our society to the next 100 years or that type of journey. So that was interesting. Ma'am जैसे बताया, Nobel Prize is the utmost highest value in terms of in amount, in terms of its significance, and in terms of its volume or something like that. Okay, not only it's a 24 karat gold, not only it's a 10 crores of rupees, Indian rupees, or 1 million of US dollar, or not only it is just given to this thing, but the work they have defining, the way they have been selected, it's a away inspiring. Okay, nobody can think that how topmost work they have been selected. So all these things, all these mysteries, all this information, so in our Nobel Prize galleries we have placed in our Rajkot, Patan, Bhavnagar. Even though there is no Nobel Prize in the mathematics, for Bhuj we have a Fields Medal, which is also equivalent to Nobel Prize, but it has given to the scientists or mathematicians who are under 40 years. So that type of, and it's also very tough to get that selection or nomination. So Nobel Prize is a struggle of all the things, and the Nobel laureate, they are not just like the persons or the people like they are fed with the silver spoon. They come with lots of struggle to that time. Okay, and they are not like that young age or something like that. One must be 99, 100 or the last age, and they are getting the recognition. Their work 30 years, 40 years like before, and their work is not like a today's like work. So they have given that doctrine or that philosophy, that way that universe is running. It's a principle. Okay, imagine that ma'am बताया कि 12-13 people India or Indian origin they have received this Nobel laureate. 1930 we have our first Nobel laureate in physics is our Sir C.V. Raman. Okay, and 1930 he was a clerk in that time, working in a farm in Kolkata and living in a very thatched house, having a just like our parapet जी हम लोग बात करते हैं ना इसके जैसे ऊपर में कुछ वो सामान हैंडमेड सामान में लेकर के he has prepared that spectroscopy model and he has propagated this Raman effect, how light scatter and how that becomes the fundamental part, and that's the way today we are working and communicating so easily. Okay, the principle is not visible but the application is like our optical cables, our communications, our all types of computer development, all these types coming from like that way. Like Ronald Russ, he was a American physicist, biologist, medical expert. So he worked in the India, taken the sample from the Hyderabad, and when he has analyzed that thing and he has propagated the theory of that malaria and mosquito parasite, so that he has saved millions of lives. Okay, so everything in chemistry, physics or medicine, all the things, even the latter parts, that economics model that has been also propagated, that also been proposed by the laureates, it is also a game changer in every times. So lot of things has to be there. So nobody knows also they how they came to know also. Suppose आपको Nobel Prize मिल गया, that announcement is also very suspicious and very curious also. Nobody knows. Somebody must be traveling, somebody must this thing, and till that them, suppose if you are applying for a job, or if today if you are applying for some sort of nomination, there are so much nominations are there, this prize, that prize, send your nomination, this is your last date, or this is the pro forma, you have to upload this document online, offline. These are the things we know, that whether we are getting selection or we are not getting the call, but we know that we have applied for this one. But Nobel Prize is such a prize, nobody knows who has nominated, nobody can directly apply. Okay, and who don't know also who is nominating to whom, for which work, which year, everything is on the dark. Okay, on the blank. Okay, similarly, suppose as a similar very early fine morning, evening or late evening or late night, you might have sleeping, you might be traveling, you might be reading, so there is a call, telephone call will be coming from the Stockholm, Dr. so and so or Mr. so and so, so you have been called, you have been nominated, you have been selected for this Nobel Prize, this thing. So you imagine that moment, what would be the feelings, what would be the things for the laureate, the person himself, the family and the things. One call can change the entire personality and the perception of the family, the person and the things. Okay, so this is that beauty of this prize. Lots of excitement is there. If you are visiting to our Nobel Prize galleries, which are really exciting and amazing way of this thing, you will be seeing that you are attending this class which was taken by Madam Peri Curie. Okay, यहाँ पे suppose there is if you are sitting with the school student and things and take a picture, nobody can deny that the Madam Peri is live, or this is the you have taken the picture with the portrait or something like that. So like Einstein is sitting on the table, he is discussing something. If you are sitting on the next chair which was made for you also and taken a photograph, and you can show that today I met Einstein at Nobel Prize Gallery in RSC Rajkot. Similarly in Bhavnagar we have medicine gallery where you have all type of Hargobind Khurana and all these things like that way. We took a lot of time to conceptualize किसके ब्रश रखना ही है, किसके फोटो रखना ही है. सपोज 1901 से आज तक सपोज 200 लरेट्स आए, सपोज हम सारा का फोटो लगाएंगे तो इट लुक्स लाइक ये जैसे हमारे यहाँ पे होता है ना, हमारा जो ये समाज में ये सब हमारा ट्रस्टी है, ये सब हमारा हमारा पिलो से मैंने क्या बोलते हैं, दाता है, बाड़ी है, वो सब ये सब दान दे करके वो लोगों को ये करता है. बट इट इज नॉट लाइक दैट. You will be finding whatever the research publication that has been prepared or published by the laureate, what are the main instrumentation they are using that time, what are the consequencing, whatever all these things, some sort of spinach and all things, the thing you can find that way. And we have our curators and directors and guides also, they have compiled literature detailed this thing, which family they got, father, mother and son, they got the Nobel prize in so and so things. This is Nobel family, so all members are Nobel laureates. Who are the members who can get, both husband wife, they got the Nobel prize, Nobel couple. Who are the laureates who have got 2 Nobel prize in 2 disciplines, one is chemistry, one is medicine, one is biology and one is this thing. So lots of excitement, lots of trivias are there. Even a professor in chemistry, he or she might be getting the Nobel prize in the other field also. It is not like that you are in a MSc physics or PhD physics, you will be getting only that thing. Okay, so today the program is we have to take our student at our visitors, our faculties and our ecosystem, educational system to that beautiful movement where all these 14 laureates, they are getting felicitated by the king of Sweden and the Oslo, Norway. Okay, it's a very excitement, just like our nowadays all these receptions are happening in our societies, in our places. It's a much more than it is. The celebration start 1 week before. Okay, the laureates are just like the royal guests, so they are also getting the royal treat, okay, by the kings, by the royal family there. And today this program is happening in the Stockholm. It's a beautiful banquet hall where they have to call the laureates, their family, their peer groups, they are all here. So one by one, so by the procedure, it's just like a protocol, government protocol, like our program when our PM or CM, they like that. It is just like that way, very disciplined, very honored program. It is followed by some live music and orchestra, then it is followed by the dinner. Okay, and the next day the laureate are really the laureate, so they are become the resources of the entire planet, entire globe. They are not belong to, suppose they may be from the native from the US or any other places, but they are noble people for the noble planet. Okay, so they have to go to school, college, university, states, countries, and to inspire the students and their inspiration for humankind. Not like that I would be a great scientist, I have to only 100 papers, or I have to be the director, or all this like that way. Okay, so whenever you are talking to getting a chance to have a word with the Nobel laureates, so he or she will not talk about that high volume equations, graphs, presentation like that way. Every word counts. Okay, you will be getting some few words, and that few words will be mesmerize you. Okay, it is just like it's a turning point, might be carry your in your thought process or something like that way. So we would like to have that happening in our system, in our among our students, our teachers, all our members, enthusiastic. So they have to understand that how this thing they are. So that is the reason India is celebrating National Science Day on 28th February. Not like that it is the birthday of C.V. Raman, okay, because it is the day when the C.V. Raman has discovered or announced this Raman's effect, and for that thing he was awarded Nobel Prize in 1930. So that was also a reason when in 1970, when our the then Prime Minister Mrs. Indira Gandhi was PM of India, one small girl of class 7 or 8 from Hyderabad, she sent a letter, postcard, that respected Prime Minister, so we are at 1970 and our country has got the freedom in 1948. We have so many infrastructure, so many development, so many labs, but why we don't have another Nobel laureate who has got 1930? Okay, 13 or 13 17 years before the independence we got the first Nobel laureate, but after that 30 years why we don't have a second Nobel laureate or second nomination? So the PM has just forwarded as the protocol, he has forwarded to all the department heads of the Department of Science, Ministry, Department, all these things. So everybody was wondering what should be the answer for this one line postcard question. So finally they have sent, we have developed so many things, we have so many rockets, so many reactors, so many this thing, but that doesn't satisfy the child's query. Okay, then the 1996 the Department of Science and Technology under that department institution cell, that is National Council for Science, Technology, Communication, NCSTC, they have decided that we have to make a day open for science, all the day for our student, our community members, when they have to come to the nearby science institution and understand what science is exactly, how they are going to help them, how they have to get excited, and how they have to bring that prime thought that how the Nobel people think or like that way. So that's the reason from 97 onward we are celebrating this 28th of February as a National Science Day, just to inculcate that type of scientific spirit and that curiosity which would be going to be as a lifelong learning experience for everyone. So that's the reason we thought that this Nobel Prize Day, which is the death anniversary of Alfred Nobel, who is a great scientist. His life is very glamorous, as well as he is a very topmost industrialist and having highest patent. He is such a great researcher. He has 385 plus patent in his name. अभी तक किसी के नाम में इतना नहीं होगा. Okay, but that last time how he's changed his thought process and how he's changed mind, that seeing any incident, all these things are beautiful story to listen to and to follow also. So for these things we have to just bring that glamorous, the excitement, the basic things. So the and to connect with this year's Nobel laureate, so that we thought that we have to bring this movement to our state, our country. So that's the reason with this program, and with the support of Honorable Vice Chancellor and Prerna Ma'am and all our faculties here. So this program is going on live, and parallelly also the similar program is also being arranged at the galleries. And with our interactions we have to understand that how important this year's Nobel work, Nobel Prize, Nobel laureate, and also like when they have to also going this thing, we have arranged our Nobel banquet also here, and to this program we have to culminated with the Nobel dinner. Okay, in addition to that our team also designed some beautiful creative Nobel ideas for these things, which will be also showcased to all of you. And I think I request that whenever you have time, just have a look into that our booklet, as well as take some time to visit any one or all 4 science galleries Nobel Prize at Patan, Bhavnagar, Bhuj and Rajkot, and see that how you as a teacher educator or as a science communicator or as a parents educator or whoever may be, it can be get some inspiration from this type of incident. So we are very much thankful to IIT and Honorable Vice Chancellor sir, all our faculties and all our staff members who are working at our RSC, DSC, and this also state S&T council members also. Our sincere thanks and regards to our Department of Science and Technology, our secretary Ms. P. Bharti ma'am, who is also very supportive and very encouraging this type of activities for our younger generation to come up with this thing. So I hope that you enjoy this day, connect with the Nobel laureate and understand their work, their hardship and their challenges, and see that how science has taken as a beautiful mission, and it has all powers and a purpose to solve, to resolve all the problems and challenges of our people and our planet together. So with this word, I thanks all of you for your attending this very auspicious program, and I wish you will be getting some sort of insight which will be the change maker, and be here to have the glimpse of Nobel Prize ceremony at Stockholm and Oslo this evening. Thank you.
Thank you so much, sir, for your motivating words. Noble people for noble planet, sir has rightly mentioned. Now I would like to invite our chief guest of the program, Dr. R.C. Patel, sir, Vice Chancellor, sir, IIT, for presidential address. Welcome.
Namaskar, good evening to all of you. Dr. Narottam Sahu, the advisor and member secretary of Gujarat Council on Science and Technology, popularly known as GUJCOST. Professor Prerna Selath, Director, Center of Education at IITE. Dr. Sanjay Thakur, former Principal, Sri M.N. Shukla College of Education, which was part of IIT for some time. So for him it is coming home. Dr. Rakesh Rawal, Dean, Department of Medical Biotechnology, GBU. We all know GBU is one of its kind in the country. Dr. Anag Bhaumik, Technocrat from IIT Gandhinagar. Dr. Poonam Bhargava, Principal Scientific Officer, GUJCOST. The staff members of GUJCOST, IIT, dear students who are here in front of us, and those who have joined virtually, जैसे अभी नरोत्तम साहू सर ने बताया, I think virtually at 33 centers they have joined. So then all those students also, students and all invited guests who have joined virtually. I also join Dr. Professor Prerna and Dr. Narottam Sahu in welcoming all of you to a special program in order to sensitize and bring awareness about Nobel laureates and the entire process of selection of Nobel laureates. In fact, I had prepared something which has already been shared by Professor Prerna and Dr. Narottam Sahu. However, I'll say something. एक जैसे ये बताया बचपन से ही ये मिस्टर नोबेल उनका शौक ही रहा था विस्फोटक चीज़ों के साथ खेलना. राइट फ्रॉम दी चाइल्डहुड इनका ये शौक था और उन्होंने पहले ही ऐसा एक बनाया विच वॉज लेटर ऑन गिवन नेम डायनामाइट. हमें सबको मालूम है. एक्सीडेंटली ऐसा हुआ एक बार, ऐसे ही एक विस्फोट में उनके भाई का डेथ हुआ और मीडिया पीपल ने बाय मिस्टेक इनका नाम लिख दिया. अल्फ्रेड नोबेल का डेथ हुआ जो खुद विस्फोट के साथ खेलते थे. तो उनको मौत का सौदागर भी बताया, बहुत सारी चीज़ें उनके बारे में बताई. तो दैट इन फैक्ट दैट मिस रिपोर्टिंग इन मीडिया टच हिज लाइफ and this idea of giving Nobel Prize I think came from that. and उस समय उनके पास जितनी भी प्रॉपर्टी थी, आज के दिन में भी बहुत ज़्यादा है समझो, उनका ट्रस्ट बनाया जैसे प्रेरणा मैडम ने बताया, एंड उसके इंटरेस्ट से आज भी दिस नोबेल प्राइज इज गिवन. एंड दिस इज एज जैसे बताया कि इट इज़ प्रेस्टिजियस इवन आफ्टर 125 ईयर्स. ऐसा नहीं हुआ कि उसकी प्रेस्टीज, उसकी वैल्यू कोई भी जगह पे कम हुई हो. तो आज भी एक नाउ वी आर सेलिब्रेटिंग 125th ईयर. तो ये बहुत ही एक इम्पॉर्टेंट ऑनर रहा है फॉर पीपल, नॉट ओनली इन टर्म्स ऑफ मनी. पैसा तो एक एस्पेक्ट है उसका, बट द प्रेस्टीज, जैसे बताया ना, नोबल लॉरिएट्स, नोबल कपल, नोबल फैमिली, नोबल दिस, ऐसे बहुत है। तो मैं भी सर्च कर रहा था, तो गुजरात और इंडिया में देर आर अराउंड 13, और मैं प्राउडली बता सकता हूँ वन ऑफ देम इज फ्रॉम द यूनिवर्सिटी वेयर आई हैव स्पेंड 31 ईयर्स। MS यूनिवर्सिटी के है, या वेंकट रामन, हु इज पॉपुलरली नोन एज वेंकी। मेरा एक फोटो है, आप लोगों ने देखा होगा कि जब नरोत्तम साहू जी बोल रहे थे तो आई वॉज सर्चिंग समथिंग, इनफैक्ट आई वॉज सर्चिंग दैट फोटो, मेरा उनके साथ था। अगर होता तो यहाँ मैं आई वॉन्टेड टू प्रोजेक्ट इट, समहाउ वो नहीं, आई कुडंट ट्रेस। तो ये वेंकटेश रामन, जैसे अभी साहू सर ने बताया कि ज़रूरी नहीं कि यू आर स्टडिंग MSc फिजिक्स तो आप फिजिक्स में ही आगे जाओगे। ये जो वेंकटेश रामकृष्णन है, he basically studied, I think, BSc biology from our university, and he got Nobel Prize in 2009 in chemistry, राइबोसोम का आई थिंक स्ट्रक्चर और ऐसा कुछ बनाने के लिए। तो इमेजिन कि जो ये इंटरडिसिप्लिनरी मल्टीडिसिप्लिनरी जिस प्रकार से जो रिसर्चेज और काम होता है, तो ये दिस इज़ व्हाट ही वाज मीन्स अबाउट वेंकटेश, आई कैन से वेंकटेश रामकृष्णन। बायोलॉजी में पढ़ाई करने के बाद गॉट नोबेल प्राइज इन केमिस्ट्री, इमेजिन। तो इट आई थिंक दिस सच काइंड ऑफ स्टोरीज ऑफ डिफरेंट नोबेल लॉरिएट्स, जैसे बताया मैडम क्यूरी को 2 बार, एंड आई थिंक दैट इज़ द ओनली फैमिली जिनके पास 5 है टोटल। तो ऐसी सब इंफॉर्मेशन तो गूगल से हमें बहुत मिलेगी, बट व्हाट आई एम सिंपली ट्राइंग टू से इज कि गुजकोस को मुझे तो बहुत अभिनंदन देना चाहिए सर, कि यू हैव थॉट ऑफ दिस काइंड ऑफ प्रोग्राम, और दूसरा कि ये प्रोग्राम विथ IIT, और हम दोनों जैसे उन्होंने बताया ना, सर इज ऑलवेज हेल्पिंग, इट इज़ नॉट लाइक दिस, इट इज़ अ सिम्बायोटिक रिलेशनशिप दैट वी शेयर, जिसमें दोनों को फायदा होता है, हमें भी फायदा है, इट इज़ नॉट पैरासाइटिक, ये बिल्कुल सिम्बायोटिक रिलेशनशिप है हमारी, जिससे इसी आवर स्टूडेंट्स आर ऑल्सो गेटिंग लॉट ऑफ बेनिफिट। तो बड़ा इंपॉर्टेंट चीज़ ये है, एंड आई थिंक टुगेदर दिस वे वी कैन डेफिनेटली ग्रो। तो ये जो 5 फील्ड में था, इसके बाद 6 फील्ड भी ऐड किया, बट देन बहुत इंपॉर्टेंट चीज़ है हम सबके लिए वो कि थिंक लेट अस गेट टू नो अबाउट सच नोबेल लॉरिएट्स। एक एक को बारे में सुनेंगे तो हमें पता चलेगा, देन व्हाई कांट आई, है ना, आई कैन ऑल्सो कंट्रीब्यूट। तो उस तरीके से बेसिकली बात है। तो आई थिंक ऑन दिस ओकेजन I also join hands with other colleagues, and especially Dr. Narottam Sahu from GUJCOST in welcoming all of you to this program, which will definitely bring awareness and sensitize all of us about this entire process of selection of Nobel laureates and their lifestyle. थैंक यू वेरी मच, है ना। तो आई थिंक दिस इज़ अ वेरी गुड अपॉर्चुनिटी फॉर ऑल ऑफ अस, टू मोटिवेट आवर सेल्फ, because what is more important is, there are various ways by which we can get motivated. So one of the best ways is, it is a self motivation. So I think such programs will definitely help us in motivating us in learning more and more. And once again, sir, thank you very much for thinking of this symbiotic relationship with IIT. And I once again take this opportunity to invite all the 3 guests who are from 3 different disciplines. एक एजुकेशनिस्ट भी है, सो एजुकेशनिस्ट है, मेडिकल साइंस है, टेक्नोलॉजी है. सो वी on behalf of everybody and on my personal behalf, I welcome all of you to IIT and this special program which is organized in order to sensitize everyone. Thank you very much. Welcome all of you.
Thank you so much, sir. Now this is time for, as Sahu sir has rightly mentioned, that our team has prepared the Nobel card. अच्छा साहब आए, ठीक है. So just we are waiting for Meanwhile, the team can play the video which is made on the occasion of Nobel Prize Day. Thank you. Now I would like to request all our dignitaries to unveil the Nobel cards on the occasion of this Nobel Prize Day celebrations. They are available on the tables. Please give a huge round of applause. These are basically informative cards which contains all the Nobel laureates from each of our. And on this occasion, we are also releasing the e-book version of the Nobel Prize, which will be English and as well as Gujarati language. So I would like to request the IT team to please unveil the Nobel Prize booklet 2025. Thank you. Now I would like to request our dignitaries to occupy the front seats so that we can begin with the expert sessions. Our first talk will be on the Nobel Prize in Chemistry 2025. The prize in 25 was awarded for the development of metal organic frameworks. So for that I would like to invite Dr. Sanjay Thakur sir on the dais. Sir is former principal at Sri M.N. Shukla College of Education. Sir, over to you for your talk.
हेलो नमस्कार सौने today is a very special day. We are also joining at Sweden the Nobel laureate distribution for the award program. So we have started very early. So namaskar, respected Vice Chancellor Sir, Professor R.C. Patel Sir, respected Dr. Narottam Sahu Sir, Advisor and a Member Secretary, GUJCOST, respected Dr. Rakesh Rawal Sir, respected Dr. Anak Bhomik Sir, Dr. Poonam Bhargava Madam, Prerna Selat Madam, Paras Uchad Sir, all GUJCOST team, all faculty members of IITE, and my dear students. You are not students, you are not teachers. You are to be teachers. So it's very important program for us. Education fraternity should think about it, and we can motivate our students. We can create curiosity among the students to do something which is in science. First of all, I would like to forward my thanks to GUJCOST and IIT for giving me an opportunity to talk something about Nobel Prize in Chemistry. As a student, I would like to talk something about Nobel Prize in Chemistry 2025. Next, please. Okay. As earlier Dr. Prerna Selat ma'am and Sahu sir have also discussed, this is given to the greatest benefit to humankind according to Alfred Nobel's will. So I am not going to repeat anything. Nobel Prize in Chemistry. Rasayan Shastra ma Nobel Prize. Basic thing I am going to discuss with you and all the students joining from 34 centers. They are also very eager to know something more and detail basic thing. Which research work they have carried out and for what this Nobel Prize was given. આપ સૌને એક ખાસ વાત કરીશ કે આની પાછળ જે નોબેલ laureateને આ પારિતોષિક મળ્યું છે એની પાછળના ઘણા રહસ્યો છે અને એની પાછળનું અથાગ મહેનત છે, રિસર્ચ છે, એની પાછળનું કમિટમેન્ટ છે. વર્ષો સુધી એની પાછળ કામ કરીને એમણે આ પ્રાપ્ત કરીને સમાજને, વિશ્વને એમણે જે કંઈ હ્યુમેનિટી માટેનું સંશોધન છે એના માટે આપેલું છે. Particularly, the Nobel Prize in Chemistry is awarded to person who made the most important chemical discovery in improvement. Second thing, in other words, the prize awarded to people who have provided us with knowledge about the composition of different substances, what atoms and molecules look like, how and why they react with each other, and even how we can create new molecules. The basic thing, which we studied right from the standard 5th. And it's a very beautiful thing that all Nobel are starting from the basic thing, basic sciences. And they reach to the higher level of application because कुतूहल, जिज्ञासा, क्यूरियोसिटी से ही ज्ञान प्राप्त करने की प्रक्रिया शुरू होती है. देन नॉलेज, देन साइंस, देन Gnan, Vignan, technology, and then applied sciences. This is the process. So we have to lead our students from curiosity to applied sciences. So our responsibility as a teacher and as a student, you try to know something. What is the purpose of this program? You are going to know so many things about all these Nobel laureates and their achievements and researches. But what we can take today with us, आज ये प्रोग्राम में हम शामिल हुए तो हम क्या ले जा सकते हैं अपने साथ? वो क्यूरियोसिटी और जो उन्होंने काम किया उसके बारे में थोड़ा हम जानेंगे. Particularly it is known as Chemistry Nobel Prize for MOF, for the development of metal organic frameworks. We can say in Gujarati ધાતુ કાર્બનિક સંરચનાના વિકાસ માટે આ નોબેલ પારિતોષિક મળેલું છે. બહુ સરળ બે શબ્દો જ છે, ત્રણ શબ્દો જ છે આમ તો. વેરી ઇઝી થિંગ ટુ અન્ડરસ્ટેન્ડ. પણ કામ, વર્ક ઇઝ the biggest work in the world. And 3 Nobelists are there. One, Richard Robson from University of Melbourne, Australia. He's 88 years old, professor. Another is Susumu Kitagata from Japan, 74-year-old professor. And Omar Yagi, basically from Jordan and University of California, US citizen now. He is of 60 years. You can see the range of researcher. The very interesting thing is how for our education faculty this is very important. Sailat Madam, R.C. Patel sir. The root of this research is in planning, lesson. When Professor Richard Robson was planning the lesson for the lecture, the spark came in his mind that can we develop some material or substances or structure, new structure? So our lesson planning is very important, dear friends, for teachers. I can say it's boring part of any training program for the teachers. I realize that आपको ये पसंद कम है, सबसे ज़्यादा आपको नापसंद क्या है BA ट्रेनिंग में? Lesson planning. But you see the root of this research in his planning. Second thing, for students, Omar Yagi was a student in US when he came to US. And while learning chemistry, basic chemistry, there was some spark in his mind also. So let's develop something new. Let's develop some new substances. And then he created the research work in 1974. Richard Robson started his work after 50 years of hard work and research. 50 વર્ષ સુધી આખું કામ કરી, તપસ્યા જેને કહેવાય ને આપણા ઋષિમુનિઓ જે કરતા હતા એ પ્રકારનું કામ કરીને એમને આપણે જે સ્ટ્રક્ચર આપ્યું છે અત્યારે એના બધા એપ્લિકેશન્સ છે એ ઉપયોગમાં છે. અત્યારે આપણે ઉપયોગમાં લઈ રહ્યા છીએ. એના ઉપર આધારિત જે કંઈ સબસ્ટન્સીસ છે, જે પદાર્થો છે એનો ઉપયોગ આપણે કરીએ છીએ. થોડીક બેઝિક ઇન્ફોર્મેશન એના વિશેની જોઈશું આપણે કે ધાતુ કાર્બનિક સંરચનાનો વિકાસ, ધ ડેવલપમેન્ટ ઓફ MOF, ડેવલપમેન્ટ ઓફ મેટલ ઓર્ગેનિક ફ્રેમવર્ક, સંરચના, માળખું આપણે એવું કહી શકીએ. એમાં આપણે right from the standard 8, 9 we are learning bonding. બંધ બનાવીએ છીએ, સહસંયોગ બંધ, covalent bond, ionic bond, basic science is there. અને રસાયણશાસ્ત્રના આપણા જે 33 સેન્ટર છે એના માટે આ ખાસ ગુજરાતીમાં મેં એનું ટ્રાન્સલેટ કર્યું છે. રસાયણશાસ્ત્રના મૂળભૂત સિદ્ધાંતોનો ઉપયોગ કરીને વિશિષ્ટ પ્રકારનું માળખું ધરાવતા પદાર્થ વિકસિત કરવામાં આવે જેના માટે નોબેલ પારિતોષિક આપવામાં આવ્યું છે. MOFમાં વિવિધ ઘટકો બદલાતા માળખાનું સ્વરૂપ બદલાય છે અને આ એવું વિશિષ્ટ પ્રકારનું ડિફરન્ટ ટાઈપ ઓફ સ્ટ્રક્ચર વિચ હેઝ કેવિટીઝ, પોલાણ છે, છિદ્રો છે, પોરસ છે જે કોઈ પદાર્થને અંદર શોષી શકે છે અને એનો ઉપયોગ જુદી જુદી રીતે આપણે કરી શકીએ છીએ અને એને મુક્ત પણ કરી શકે છે. વેરી વેરી ઇન્ટરેસ્ટિંગ થિંગ. So they have picked up the basic science and prepared this MOF. If we change the components of that structure, you will get the different products and substances. And even in that cavities, they can absorb the gases or substances, and also it can release the substances or gases. So it can be used in future. Okay. Now, metal organic frameworks are porous material in which metal ion, one component is metal, another component is organic compound, and long carbon based molecular formal crystal with built-in cavities. By varying building blocks, specific substances can be captured and stored inside the cavities. Following pioneering work by Richard Robson around the turn of millennium, Susumu Kitagawa and Omar Yagi developed more flexible and stable MOFs. These are the possible use of example. There's harvest the water from the air. In desert area, it captures carbon dioxide. So we have lots of problem with CO2. Okay, it can store toxic gases and or catalytic chemical reactions. So in simple way, you can see the chemistry laureate have created a completely new material. They have developed new material. Are you thinking about developing something new? As a student, you should think about. So we should have laboratories in our schools and colleges. We have very good laboratories in IIT. So we can use it. We can do it. नए नए प्रयोग कर सकते हैं हम, काम कर सकते हैं, सोच सकते हैं क्या ये हो सकता है, टीचर्स को पूछ सकते हैं हम, विद्यार्थियों के लिए वे क्या कर सकते हैं. So teachers' responsibility to create curiosity among the students to ask something, to do something. Otherwise, क्यूरियोसिटी जागृत नहीं होगी तो कैसे हो पाएगा. तो क्यूरियोसिटी जागृत करना हमारा टीचर का काम है. सो MOF इज आर मेड अप ऑफ मेटल आयन एंड ऑर्गेनिक મોલિક્યુલ. ઘન અને છિદ્રાળુ એવા નવા પદાર્થની રચના, ધાતુ આયનો અને કાર્બનિક અણુઓની બનેલી રચના અથવા માળખું છે. અને ધાતુ આયનો એકબીજા સાથે કાર્બનિક અણુઓની હારમાળા રચીને એ હારમાંથી જોડાઈને एक त्रिपरिमाणीय माળખું બનાવે. It can be one dimension, 2 dimension or 3 dimension. And if it is in 2 or 3 dimension, it can create big cavities. પોલાણો અને છિદ્રનો ભાગ એની અંદર આપણા જે ઇમેજિનેશન કરતાં પણ વધારે જગ્યાનો એ ડેવલપ કરે છે, વિકસિત કરે છે. અને એના માટેનું એક સિમ્પલ, if you will visit Nobel site, you will go through this video. I have taken 4 parts of this video. In one part you can see the one part is metal shining. Okay, another part is carbon, metal, organic. Okay, organic. And by joining all these metal and organic polymers, when it joins with another, in the second you can see the 3-dimensional framework like diamond, right? So it will 3-dimensional, and in between there is cavity, porous material. And you can see in the third left side down, any gas or liquid can go inside and it can come outside according to the chemical reaction. In fourth also they have shown, in right next picture you can see the Richard Robson has prepared a model of that. It's a very small substances, but this is the model. Now another, this is the real Richard Robson has prepared this structure like diamond. You know very well the structure of diamond. It is hardest substance. Okay, there is no cavity. It is made up of only carbon. But here you can see the copper ion is used, and then nitrile is used as organic material, organic component, and they have joined this, and the new substance is formed with 3-dimensional, octagonal, hedragonal, octagonal, this type of material in different way, and it can abstract something, absorb something, and it can release something. Another, as we know the NaCl model, right? NaCl structure. But here Susumu Kitagawa has also tried to make this structure. It was a flexible MOF, molecular, and you can see the in between space, cavity, in which gases can be stored and it can be removed at certain time. So Omar Yagi, all are working in the same line, and they are thinking how to develop. There are more than thousands of substances prepared by this way with the help of this theory MOF, and it is used in different way. Okay, you can see here as a metal, zinc is there, and carbon and linkages, and then the MOF is created with this, and this cavity is very big. This metal organic framework is also, there are some parallel name, hybrid organic inorganic material, when there is connection with organic and inorganic material. Metal organic polymers, you can say the same thing. Coordination polymer, organic zeolite analogs. Zeolite you can see, burning rock, boiling rock, okay, aluminum silicate, which can porous and it can absorb, it can be used at different thing, different chemical processes. So metal organic frameworks are a class of, it is a class, and there are many substances and many chemicals produced under this MOF theory, made up of metal connected by organic ligands. Think of metal and organic compounds as a building blocks. These are the building block, basic blocks. કોઈ પણ સંરચના બનાવવા માટેના જે બેઝિક આધાર છે એ આ મેટલ અને ઓર્ગેનિક સબસ્ટન્સીસ છે અને બિલ્ડિંગ બ્લોક્સમાં ચેન્જ કરીને જે પ્રકારની તમારે પદાર્થ બનાવો એ બનાવી શકાય. યુ કેન ઓલ્સો ડેવલપ યોર, ઇફ યુ આર વર્કિંગ ઇન ધ કેમિસ્ટ્રી, you try to develop something new from this theory also. You can try. આઈઆઈટીમાંથી હમણાં બેને વાત કરીને પ્રેરણા સેલત મેમે, તો તમે પણ ટ્રાય કરી શકો. હવે એમઓએફમાં નહીં પણ તમે પેટન્ટ માટે ટ્રાય જરૂર કરી શકો છો, નવો પદાર્થ બનાવી શકો. ઓલ ઓવર ગુજરાત બધાને આ કયા પ્રકારની મેટલ આમાં વપરાય છે તો એના માટેની ખાસ મેટલ ક્લસ્ટર ઇન એમાં ઇન્ક્લુડેડ M3O, where aluminium, iron, chromium is used, zinc M4O, valency and structure related metals are there. So here for teachers the important thing is to teach periodic table very nicely, because all these metals have their different properties. Metallic group has also different properties, and each metal has its own property. Okay, so it can be used in this M4 in Zn, M6O4 OH4, zirconium, hafnium, beryllium, and then titanium. These are the metals mostly used in different. You can see the structure formed by linkers, oxygen and metal. A very good thing and very good picture to understand how it forms MOF, what is used, how it be converted into MOF. A very good material, very good substance which can be used for different purposes. So for that you can, if you want to study more in detail about the which substances are produced, MOF are available in the market also now. Now it is available in the market. You can also know the price of that structure and material. Okay. So, which type of metal used for which type of properties? Copper, nickel, cobalt, catalytic, iron, magnetic, catalytic, biocompatible, titanium, redox, activity, photochemical, biocompatible, manganese, catalytic and high capitans, zinc, catalytic and biocompatible. These are the different area. Now organic ligands. There are many organic ligands. Those who are studying in chemistry, MSc, they have very good information about this ligand, and this boric acid, carboxylic acid we can use as a ligand, and it can increase the structure of that MOF. Okay. A boronic acid has a general structure RbOH2, where R is an anybody from chemistry, MSc, BSc, R is organic group. You can attach organic group. Okay, a carboxylic acid is an organic compound, RCOOH. Very easy, but you have to carry out different experiment for the longer time, then you will get the result how you can develop a steady material substances. Okay, so and there are some system to give a particular name to particular MOF, and it is a very detailed scientific process, and some names are given according to the institute or university also. So you can see the MOF 303, MIL 101, ZIF 8, CALF 20. There are different things used for the different purpose. Suppose MOF 303 is the name of the specific metal organic framework composed of aluminum ions and organic linkers. Its full name is, chemical name is aluminum 1H perazole 3,5 dicarboxylic hydroxide. हम कैसे नामकरण करते हैं? It's a very beautiful process. So we should enjoy this nomenclature of this MOF. What are the characteristics? High porosity, छिद्रालुता, जैसे स्पंज देखा है आपने, हमें दिखता है इतना ही, लेकिन अब जब आप पानी में रखोगे तो वो कैविटी में पानी सोच लेगा, ऐसा ये मटेरियल है. सेकंड थिंग, allows for significant storage and interaction. High porosity, tunability, structure and properties can be designed by changing metal and linker components. अब जैसा चाहे ऐसा चेंज कर सकते हैं. Sustainability can be made highly stable even against corrosive gases also. This is the characteristics. And where are the application of this MOF? These are the area. Okay, gas storage and separation, capturing CO2. So many issues related to our pollution and environmental issues, climate change can be solved by using all this in industry as well as in our cities also. Catalytic, acting as catalyst or catalytic support, sensing, detecting chemical and pollutants, and drug delivery, encapsulating and releasing therapeutic agents in medicine and in cancer treatment also it can be used. So there are many uses, many area. अब ज़्यादा मैं डिटेल में आप एक मैं वेबसाइट दे रहा हूँ, नोबेल की तो वेबसाइट है ही, लेकिन यू कैन गो थ्रू दिस वेबसाइट and you will get more detailed information courtesy thanks to this institution. And what is our role as a teacher? What is role of students? So we have tried to understand what they carried out, and there are many things which are used in a daily life जो कि ये तैयार की गई है. बहुत समय गया इसलिए ज़्यादा इसमें डिटेल में अब डिस्कशन नहीं करते. तो इट्स माय प्लेजर टू डिलीवर माय टॉक एज ए स्टूडेंट ऑफ केमिस्ट्री. एज ए स्टूडेंट ऑफ केमिस्ट्री, प्लीज़ ट्राई टू लव दिस सब्जेक्ट, ट्राई टू लव दिस बेसिक सब्जेक्ट्स, बेसिक साइंसेस. आप इतना प्यार कीजिए, फिजिक्स, केमिस्ट्री, बायोलॉजी को प्यार कीजिए, और एक क्यूरियोसिटी के साथ. ये जो मैंने अभी रखा था, क्यूरियोसिटी में से ही नॉलेज आएगा. ऑल थिंग कैन नॉट बी वर्चुअल. फॉर द साइंस, फॉर द रिसर्च, वी शुड वर्क इन लेबोरेटरी, फेस टू फेस वर्किंग. सो हमारे जो भी 33 सेंटर्स पर बच्चे देख रहे हैं, उन सभी को युवा प्रतिभा है, वो बच्चे हैं, यंग साइंटिस्ट है, उनको बहुत सारी बधाइयाँ कि आप आज ये सब समझ रहे, देख रहे. और यहाँ पर भी जो बैठे हैं स्टूडेंट्स हमारे, चार्मिंग फेस, यू आर द फ्यूचर टीचर. सो यू कैन डेवलप इंटरेस्ट अमंग द स्टूडेंट्स टू डू समथिंग. एंड थैंक यू वेरी मच सर, डॉक्टर साहू सर. ही इज़ कमिटेड साइंटिस्ट, रियल साइंटिस्ट. Poonam Bhargava madam and all the team members of this GUJCOST, they are 24 hours ready for the science and GUJCOST. I would like to congratulate GUJCOST and also IIT for hosting this a special event. This is the worldwide event, so this is a very special program for the IIT. And मैं एक ખાસ વાત કહું કે હું આજ સંસ્થાનો 4 વર્ષ અહીંયા કામ કર્યું છે અમે, એનો અમને આનંદ છે, અને ફરીવાર આજે અહીંયા આવવાની તક મળી. સર થેન્ક યુ વેરી મચ. સાહુ સર થેન્ક યુ વેરી મચ. એન્ડ રાવલ સર થેન્ક યુ વેરી મચ. યુ આર સિટિંગ હિયર. रिस्पेक्ट टू यू. एंड सर भौमिक सर, बहुत अच्छा लगा मुझे. पूनम भार्गव मैम, सैलत मैम और फैकल्टीज़ एंड सब आईआईटी के स्टूडेंट्स, थैंक यू वेरी मच. नमस्ते. वसुधैव कुटुंबकम की भावना यहाँ सिद्ध होती है. थैंक यू ऑल.
થેન્ક યુ સો મચ સર ફોર યોર ઇન્સ્પાયરિંગ એડ્રેસ. હું આપને વિનંતી કરીશ કે આપ 1 મિનિટ ડાયસ પર જ રહો, અને આઈ વુડ લાઇક ટુ ઇન્વાઇટ ડૉક્ટર નરોત્તમ સાહુ સર ટુ પ્લીઝ ફેલિસિટેટ અવર સબ્જેક્ટ એક્સપર્ટ ઓફ કેમિસ્ટ્રી ડૉક્ટર સંજય ઠાકર સર with a memento. Thank you, sir. નેક્સ્ટ ટોક માટે હું હવે ઇન્વાઇટ કરીશ ડૉક્ટર રાકેશ રાવલ સર. સર ડીન છે ડિપાર્ટમેન્ટ ઓફ મેડિકલ બાયોટેકનોલોજી એટ ગુજરાત બાયોટેકનોલોજી યુનિવર્સિટી. As rightly mentioned earlier also, Gujarat Biotechnological University is one of its kind university in India. So over to you, sir. Welcome.
Thank you. I can see hypoglycemia on your face. Severely deprived of glucose. And sorry for that. And I will not take much time. So when I received the call from GUJCOST that you have to address the teachers or future teachers regarding Nobel Prize in Physiology and Medicine, the condition was that it has to be simple and palatable. બને ત્યાં સુધી ગુજરાતીમાં થાય તો બહુ સારું. So it is really difficult to make it palatable, and that too in Gujarati. So I will try to do that. How many of you can understand Gujarati? Okay. So we will have a mixed version. That means English everyone knows because you responded. How many of you fall sick during the change of season? Majority of us, right? Chink aave, sardi thai, tav aave, cough thai. So what is that? That is your immune reaction towards change in weather. At the same time, many of us are allergic to pollen, dust, and so many other type. માર્કેટમાં સેન્ડવિચ જોડે સોસ ખાધો હોય ને આપણને એલર્જીક રિએક્શન ઉપડે, ઘણાને થાય. સો વોટ આર ઓલ ધીઝ? અલ્ટિમેટલી ધીસ ઇઝ અવર ઇમ્યુન સિસ્ટમ. કોવિડે આપણને બધાને શીખવાડી દીધું કે ઇમ્યુનિટી શું હોય એમ. સો this Nobel Prize was part of the immune system that we harbor, and that's why it was so popular and it was so impactful, right? આના શબ્દો પર નહીં જતા કેમ કે એમાં ઘણા બધા ટેકનિકલ જાર્ગન્સ હશે. So I will not go into each of the slide, but I will tell you how many of you are aware about immune system, immunity અથવા immune system વિશે કેટલાને ખબર છે? So those who are from biology will be aware about that, right? Immunity કેટલા ટાઈપની હોય છે? બે ટાઈપની, innate અને adaptive. Innate is what we are born with. આપણે ધરોહરમાં જે લઈને આવ્યા છે ને એ. Adaptive is how we react to the environment and develop the immunity. નાનપણમાં ધૂળમાં રમ્યા છો, ઇમ્યુનિટી સારી રહેશે. આજકાલનું જનરેશન આઈપીથી લૂછેલા ટોય, રેસ્ટ્રિક્ટેડ, બેટા બહારનું પાણી નહીં પીવાનું, કોઈના હાથનું આપેલું ખાવાનું નહીં. સો દેર આર સો મેની રેસ્ટ્રિક્શન્સ. સો વોટ હેપન્સ? અવર એડાપ્ટિવ સિસ્ટમ ઇઝ લેસ એક્સપોઝ ટુ વેરાયટી ઓફ પેથોજન્સ, અને દરેક પેથોજન ઉપર એક સિગ્નેચર હોય જેને આપણે કહીએ એન્ટીજન, જેનાથી આપણું ઇમ્યુન સિસ્ટમ ટ્રેન થાય. સરદારજી છે તો પગડી હોવી જોઈએ, है ना, मैरिड है तो चांदलो होवो જોઈએ. So there are typical characteristics, like we identify individuals, we also identify pathogens, we identify different cells. દરેક સેલની એક ટિપિકલ કેરેક્ટરિસ્ટિક હોય. તો આપણું પોતાનું ઇમ્યુનિટી આપણા પોતાના સેલને કેમ નથી મારતું? પહેલો સવાલ. Because our immune system is initially trained. ઘરમાં જેમ આપણને માતા પિતા શીખવાડે, આપણા મામા છે, આપણી માસી છે, આપણી ફોઈ છે, and that we remember કે આ બધા આપણા જ. Then we go to school, we develop friends, then we start recognizing them. And your social exposure increases. Similarly, આપણા શરીરની અંદર એક થાઇમસ ગ્લેન્ડ છે. થાઇમસ ગ્લેન્ડનું કામ શું છે? કે ટી સેલ બનાવવાના. જો આપણે આપણી ઇમ્યુન સિસ્ટમને જોઈએ ને, તો ઇમ્યુન સિસ્ટમમાં ઘણા બધા સેલ્સ છે કે જે આપણને પ્રોટેક્ટ કરે છે. એમાંથી મેજરલી જે લિમ્ફોસાઇટ, શ્વેત રક્તકણિકા, WBCs, है ना, એમાં ટી ને બી સેલ જે છે એ આપણા માટે પ્રોટેક્ટિવ કામ કરે છે. તો આ ટી સેલ જ્યારે બને ને થાઇમસમાં, ત્યારે એકદમ નેવ હોય, નવું બાળક જન્મ્યું હોય, કોઈને ઓળખે નહીં, ફાધર મધરને મેક્સિમમ ઓળખે. જેમ જેમ મોટું થાય એમ એમ બધાને ઓળખતો થાય, રિલેટિવ્સ, ફ્રેન્ડ્સ. સિમિલરલી these T cells, once they come out of thymus, they are trained for all the antigens. એટલે જે દરેક સેલ ઉપર એક એન્ટીજન છે એને ઓળખે કે આ આપણા છે. and that's why they don't react to those cells, right? Those T cells which cannot recognize the self will be immediately destroyed. કેમ? કેમ કે એ ઘાતકી છે, right? Those who recognize faintly or they bind to those antigen faintly, એને બોડી શું કરે કે ટી રેગ, આ જે છે ને ટી રેગ્યુલેટરી સેલ હિસાબે એને યુઝ કરે. હવે એને આપણે એક એનાલોજી લઈએ સ્કૂલ કે કોલેજની, તો યુઝ્યુઅલી એડમિશન માટે એક સ્ક્રીનિંગ પ્રોગ્રામ થાય. સીટ મારી પાસે 30 જ છે, એપ્લિકેશન 300 છે. શું કરવાનું? પેરેન્ટનું ઇન્ટરવ્યૂ લ્યો, સ્ટુડન્ટનું ઇન્ટરવ્યૂ લ્યો, કોઈ રિટન ટેસ્ટ લ્યો. તો સ્ક્રીનિંગ ટેસ્ટમાં શું જોવાનું હોય કે છોકરો બરોબર હોશિયાર છે કે નહીં, અને આપણા સ્કૂલમાં ચાલશે કે નહીં. ધારો કે છોકરો તોફાની છે, ઇન્ટરવ્યૂ વખતે જ તોડફોડ કરવાનું ચાલુ કરી દીધું, સાહેબના ઉપરનું પેપર વેટ લઈને ક્યાંક ઘા કર્યું, નામ કર્યું, તો તમે લેશો નહીં લ્યો. તો આવા જેટલા તોફાની ટી સેલ ડેવલપ થાય ને, બોડી એને પહેલાં એલિમિનેટ કરી દઈએ કે ભાઈ આ છોકરો ના જોઈએ આપણા સ્કૂલમાં. હવે કોઈક પ્રેશરથી, કોઈ ટ્રસ્ટીનો ભાણિયો છે, ના નથી પાડી શકવાના, એન્ટ્રી લઈ લીધી, પણ તોફાની પ્રવૃત્તિ જશે ક્યાં? એ તો છે જ. તો એવા જે હોય ને એને આપણે કાં તો મોનિટર કરીએ, મોનિટર બનાવી દઈએ કે તોફાની જે છોકરો હોય બધાને કંટ્રોલ કરી શકે. અને આ બધાએ છોકરાઓ જ્યારે પ્લેગ્રાઉન્ડમાં જાય છે રમવા, 2 ટીમ થઈ ગઈ, રમતા રમતા બાજોન થાય, તો એ ટાઈમે કંટ્રોલ કોણ કરે? તો કે રેફરી. રેફરી કોઈ ટીચર બી હોઈ શકે, સ્પોર્ટ્સ ટીચર હોય, એ યુઝ્યુઅલી રેફરી હોય. સો ટી રેગ્સ આર ધ રેફરી ઓર ધ ટીચર who controls the reaction that is caused by those groups or student, notorious. અમુક સાહેબ હોય ને આવે એટલે આખું ક્લાસરૂમ શાંત થઈ જાય. કેમ? તો કે ભય છે. So when T-Rex comes, it controls all T cells from any activation or abnormal reaction. હવે આ ટી રેક્સને આપણે કહી શકીએ કે સિક્યુરિટી ગાર્ડ છે, કોઈ પોલીસ છે કે આર્મીવાળા છે. સો હાઉ દે આર આઈડેન્ટિફાઈડ? દે આઈડેન્ટિફાઈડ બાય ધેર યુનિફોર્મ. પોલીસવાળો તો કે ખાખી હોવું જોઈએ, ટ્રાફિકવાળો તો કે સફેદ જે ડ્રેસ હોય. એન્ડ વી રિસ્પેક્ટ or we fear those part, right? So that identification is their signature. The same person ક્યારેક વર્દી વગર આવી ગયો હોય તો આપણે શું ટ્રીટ કરવાના છે? ભાઈ આ તો અહીંયાના જ છે કોક ભાઈ, we hardly bother. So the characteristic feature of Treg cell is a molecule જેનું બેચ કહીએ, એ છે FOXP3 જીન. એક જીન છે, રાઈટ? એ જીન ટી-રેગ સેલમાં હોય જ. સપોઝ આપણે એને કહીએ કે એનું આઈ કાર્ડ છે. સો ટી-રેગ સેલનું આઈ કાર્ડ જે છે એ છે FOXP3 જીન. સો વોટ વોઝ ધ બેસિસ ઓફ ધીસ નોબેલ પ્રાઇઝ? માં ઇનિશિયલી એક થિયરી આવી હતી, સેન્ટ્રલ ટોલરન્સ થિયરી. સેન્ટ્રલ ટોલરન્સ થિયરીને આપણે સ્કૂલના એડમિશન સ્ક્રીનિંગ સાથે સરખાવ્યું, એનાલોજી. તો એ શું કરે કે થાઇમસ ગ્લેન્ડ વિલ સિલેક્ટ કે આમાંથી કયા ટી સેલ સિલેક્ટ થશે ને કયા ટી સેલને મારી નાખવાના છે. સો ધોઝ ટી સેલ્સ વિચ આર એબલ ટુ રિકોગ્નાઇઝ ધ સેલ્ફ વિલ બી પાસ્ડ ફર્ધર, આગળ એને જવા દેવાનું, અને જે એબરન્ટલી રિએક્ટ કરે છે એને મારી નાખવાનું. તો ત્યાં સુધી એવું હતું કે સેન્ટ્રલ ટોલરન્સ એ એક જ મીડિયા છે કે જેનાથી આપણે બોડીના ટી સેલને કંટ્રોલ કરીએ છીએ. બટ સ્ટીલ દેર વોઝ અ ગેપ. સો ઇન 1995 ત્યાં સુધી, 1980 થી 1995 સુધી આ જ ધારણાથી લોકો જીવતા હતા કે સેન્ટ્રલ ટોલરન્સ થિયોરી જ છે આ દુનિયામાં, અને એનાથી જ આપણું ઇમ્યુન રિએક્શન કંટ્રોલ થાય છે. તો જે પહેલા નોબેલ લોરેટ છે સકાગુચી, જાપાનથી છે, એમને એવું કીધું કે ના, સેન્ટ્રલ ટોલરન્સ સિવાય પણ બોડીમાં કંઈક એવું તો છે કે જ્યારે આ ટી સેલ જે સેન્ટ્રલ ટોલરન્સ થાઇમસમાં સ્ક્રીનિંગ પાસ કર્યા પછી પણ somehow they aberrantly behave and they react. એનો મતલબ કે જે તોફાની છોકરો ભૂલથી આવી ગયો છે એડમિશન લઈને, એને કંટ્રોલ કરવા માટે પણ કંઈક જવાબદાર છે. તો એ આવ્યું પેરિફેરલ ટોલરન્સ થિયોરી, અને પેરિફેરલ ટોલરન્સ થિયોરીને નોબેલ પ્રાઇઝ આપવામાં આવ્યું. સેન્ટ્રલ ટોલરન્સ થિયોરી વોઝ એસ્ટાબ્લિશ્ડ, અને અપ ટુ 1995 નોબડી ડેર ટુ ડેવિએટ. તો આમાંથી એક શું જાણવા મળે છે કે જે લખેલું છે કે જે આપણે વાંચીએ છીએ એ જ સત્ય છે એવું માનવું નહીં. પણ આપણે શું કરીએ કે ભાઈ સામે કોણ થાય કે આપણું પછી બદનામી થાય તો. સો ઓલવેઝ ડેર ટુ ડેવિએટ ઇફ યુ હેવ એ રિયલ ગટ ફિલિંગ. તો એમને શું કર્યું, હી ડીડ એક્સપેરિમેન્ટ કે આપણું જે થાઇમસ ગ્લેન્ડ હતું કે જે ટી સેલનું સિલેક્ટ કરે છે સેન્ટ્રલ ટોલરન્સ થિયોરીનું, તો એમને અમુક માઇસ મોડેલમાં ઉંદરના એક્સપેરિમેન્ટ માટે થાઇમસ ગ્લેન્ડ કાઢી નાખ્યું. સો ઇમિડિયેટલી ધોઝ માઉસ વેર સસેપ્ટેબલ ટુ ઓટો ઇમ્યુન ડિઝીઝ. એનો મતલબ કે એમના પોતાના જ ટી સેલ એમના પોતાના જ ટાર્ગેટ સેલને મારવા માંડે. એટલે એનું પેન્ક્રિયાસ જાય, લીવર જાય, હે ને, અને અલ્ટિમેટલી ધ માઉસ વિલ ડાય. પછી એમને શું કર્યું કે થાઇમસ ગ્લેન્ડ તો કાઢી લીધું, પણ એમને બીજા હેલ્ધી માઉસમાંથી બ્લડ લઈ અને આમાં ટ્રાન્સફ્યુઝ કર્યું. મેની ઓફ ધેમ સર્વાઇવ્ડ. દેટ મીન્સ દેર ઇઝ સમથિંગ ઇન સર્ક્યુલેશન. એ બ્લડમાં કશુંક તો એવું છે કે જે પ્રોટેક્શન આપે છે. પછી એના ઊંડાણમાં ગયા ત્યારે ખબર પડી કે those healthy individuals have these Tregs which can control the T cells and they will not induce the autoimmunity. So that was the first proposition from him. At the same time, પછી એ ચાલ્યું લગભગ 2015 સુધી. એના ઉપર ઘણું કામ થયું, થાઇમસ ઉપર, પેરિફેરલ ટોલરન્સ ઉપર. અને 2005માં these two people, that is બ્રુકનો અને રેમ્સડેલ, એ બંને યુએસના છે. તો એ લોકોએ જોયું કે આ જે આઈ કાર્ડ હતું ટી-રેગનું, સિક્યુરિટી ઓફિસરનું જે આઈ કાર્ડ છે, જે જીન, એ એક સ્પેસિફિક જીન છે જેને આપણે કહીએ FOXP3. FOXP3 જીન ઇઝ કંટ્રોલિંગ ધ ડેવલપમેન્ટ ઓફ ધીઝ ટી-રેગ્સ. એટલે ટી-રેગ સેલ, હવે આપણે પોલીસમાં ભરતી થવું હોય તો શું કરવું પડે? આઈપીએસની એક્ઝામ ક્વોલિફાય કરવી પડે, રાઈટ? સિમિલરલી, જો તમારું FOXP3 જીન પ્રોપર ઇન્ટેક્ટ છે, દેટ મીન્સ યુ આર ફિટ ટુ બી એ ટી-રેગ સેલ. હવે એ ખબર કેવી રીતે પડી કે આ એક જીન છે? તો એમાં બે મોડેલ હતા. એક માઉસ મોડેલ હતું જેને સ્કર્પી માઇસ મોડેલ કહે છે, કે એ જન્મે ત્યારથી માંદવું હોય અને હાર્ડલી 2-3 વીક એની લાઈફ એ પછી મરી જાય, કેમ કે એ ઓટો ઇમ્યુનિટીથી પીડાય છે. એના પોતાના જ ઇમ્યુન સેલ એના પોતાના જ ઓર્ગનને ખતમ કરી નાખે. સિમિલરલી હ્યુમનમાં પણ એક ડિઝીઝ છે, આઈપેક્સ સિન્ડ્રોમ, IPEX. એ છે ઇમ્યુનિટી ઓફ પોલીએન્ડોક્રાઇનોપેથી એન્ડ એન્ટેરોપેથી વિચ ઇઝ એક્સ લિંક્ડ. એનો મતલબ કે આપણા એક્સ ક્રોમોઝોમમાં એવી એક જીનની ઉણપ છે જેનાથી આપણી ઇમ્યુનિટી લોસ થાય છે. પોલીએન્ડોક્રાઇનોપેથી એટલે જેટલા એન્ડોક્રાઇન ઓર્ગન છે એમાં તકલીફ પડે છે, અને એન્ટેરોપેથિક એટલે આપણા GI ટ્રેક્ટમાં તકલીફ પડે. કંઈ બી ખાઓ ઝાડા, કંઈ બી કરો ઇરિટેબલ બાઉલ સિન્ડ્રોમ થઈ જાય, જાત જાતની તકલીફો થાય, રાઈટ? તો જ્યારે એ બંનેના જીનોમ સ્ટડી કરવામાં આવ્યા ને, ત્યારે જોયું કે એમાં FOXP3 જીન જે છે એમાં મ્યુટેશન છે. એટલે એક કોઈ કોડમાં ડિફેક્ટ છે જેનાથી એ જીન તો છે પણ એનું પ્રોપર ફંક્શન નથી થઈ શકતું, રાઈટ? હવે આ બંને જણાનું ટાર્ગેટ મર્જ ક્યાં થતું હતું? સાકાગુચીએ કહ્યું કે દેર ઇઝ અ પેરિફેરલ ટોલરન્સ, અને સ્પેસિફિકલી ટી-રેગ સેલ જે છે એ ઓટો ઇમ્યુનિટીને કંટ્રોલ કરે છે. આ બંને જણાએ એવું કહ્યું કે ટી-રેગ સેલને ટી-રેગ સેલ બનાવવા માટે અથવા ફંક્શન કરવા માટે FOXP3 જીન જવાબદાર છે. અને અલ્ટિમેટલી ઓલ ઓફ ધેમ કન્ટ્રીબ્યુટેડ ટુ પેરિફેરલ ઇમ્યુન ટોલરન્સ. અને એ આપણા હેલ્થકેર સિસ્ટમને, બિકોઝ ઇમ્યુનિટી ઇઝ ફોર ઓલ, it has impacted the adaptive immunity and innate immunity to such an extent that each and every disease is somehow associated with that. હવે આપણે જોઈએ સિમ્પલ એલર્જી. એગેન ટી-રેગ સેલ ઇઝ રિક્વાયર્ડ. ટી-રેગ સેલ ઓછા માત્રામાં છે અથવા ટી-રેગ સેલમાં FOXP3નું મ્યુટેશન છે, તો એ પ્રોપર ફંક્શન નહીં કરે, and you are susceptible to any minor exposure of new antigen. અને કોઈક રોજ પાણીપુરી ખાય છે લારીનું, કંઈ નથી થતું. મારા જેવું કોઈક એકવાર જાય ને વર્ષે ડાઉન. સો સિમ્પલ એલર્જીક રિએક્શન બધાને થાય છે, સિઝનલ ચેન્જ બધાને થાય છે. ઇટ હેઝ ઇમ્પેક્ટેડ ટુ સચ એન એક્સટેન્ટ that it has impact in cancer, it has impact in organ transplantation. હવે ઓર્ગન ટ્રાન્સપ્લાન્ટેશનમાં શું થાય? કિડની ટ્રાન્સપ્લાન્ટ કરી તમે, એક રેસિપિયન્ટ છે તમે છો. સો ધ રેસિપિયન્ટ કિડની સેલ્સ have a different signature, they are not from your body. So body will try to reject it, કેમ કે એ મારું નથી, સો નોન સેલ્ફ. તો હમણાં શું કરવામાં આવે છે કે આપણે ઇમ્યુનોસપ્રેસિવ ડ્રગ આપીએ so that our immune system or cell will not attack it. પણ એનાથી શું થશે કે ઓવરઓલ ઇમ્યુનિટી ડાઉન છે તો તમને ટીબી બી થઈ જશે, હાલતા ચાલતા ડાયરિયા થઈ જશે, કશું પણ થઈ શકે, ઓપોર્ચ્યુનિસ્ટિક ઇન્ફેક્શન બધાય થાય. તો આ બધામાં જવાબદાર પાછું કોણ હતું? ટીરેગ. ટીરેગનું કામ શું? ઇમ્યુન સેલને એક્ટિવેટ નહીં થવા દેવાનું. એનો મતલબ કે ઇફ યુ હેવ સફિશિયન્ટ નંબર ઓફ ટીરેગ સેલ્સ ઇન યોર બોડી you can accept the transplant better. ઘણા કેવું હોય કે કિડની ટ્રાન્સપ્લાન્ટ ઘણા થાય છે, અમુકને ટ્રાન્સપ્લાન્ટ ફેલ ગયું, બોડીએ એક્સેપ્ટ જ ના કર્યું. વાય? કે ટી રેક્સેલ હતા જ નહીં, અથવા જે હતા એ ડિફેક્ટિવ હતા, FOXP3 મ્યુટેટેડ. સો દે વિલ નોટ બી એબલ ટુ એક્સેપ્ટ ટ્રાન્સપ્લાન્ટ. કેન્સરમાં એનું ઊંધું છે. કેન્સરમાં શું થાય છે? આપણે બોડીની અંદર જ ટ્યુમર છે તો આપણી ઇમ્યુન સિસ્ટમ કે નહીં ઓળખી શકતી? because they are our own cell which has somehow got transformed and made the tumor. Still, cancer can show different epitopes. એના પાસે પણ કેન્સર સ્પેસિફિક એન્ટીજન હોય એટલે ધારે તો દેખાડે. તો ઇનિશિયલી આપણું ઇમ્યુન સિસ્ટમ જે છે એ કંટ્રોલ કરે ટુ સમ એક્સટેન્ટ. બટ કેન્સર સેલ આર સ્માર્ટર. એ શું કરે કે ટી રેગ સેલને ભેગા કરે અને એક પ્રોટેક્ટિવ લેયર બનાવી દે. એન્ડ ટી રેગ સેલ હેઝ ગોટ ધ પાવર ટુ પ્રિવેન્ટ ધ અધર ઇમ્યુન સેલ ટુ રિકોગ્નાઇઝ ધ કેન્સર સેલ. ઘરની અંદર નાનપણમાં આપણને બચાવે કોણ? માં. બાપા આવે પહેલાં બધું સેટ કરી નાખ્યું હોય. તો ટી રેગ ઇઝ એક્ટિંગ એઝ ધ પ્રોટેક્ટર. So in cancer it is just opposite. So in cancer if you want to make your tumor susceptible to your immunity, what you have to do? Bring the Treg down. So આપણે શું યુઝ કરીએ? Treg inhibitor. હવે Treg પાસે પણ આવી ઘણી બધી આર્સેનલ છે. CTLA4, PD1 એવી જાત જાતની એની પાસે તાકાતો છે. તો એના એગેન્સ્ટમાં આપણે નવા ઇનિબિટર ડેવલપ કરીએ છીએ. Right? So these are the applications of the Treg cells, and that was one of the most important discovery in the field of peripheral immune tolerance. Thank you. Hope I could reach you.
થેન્ક યુ સો મચ સર. સરને ફેલિસિટેટ કરવા માટે અગેન હું રિક્વેસ્ટ કરીશ. વીસી સર, આઈ વુડ લાઈક ટુ ઇન્વાઇટ અવર ઓનરેબલ વાઇસ ચાન્સેલર સર. કાઢી સરે ખૂબ સરળ ભાષામાં આપણને સમજાવ્યું અને એનાલોગી સાથે. હા, thank you sir once again. Next, we are moving to the final subject. So, I would like to invite Dr. Anak Bhaumik sir from Indian Institute of Technology, Gandhinagar. Sir will talk about Nobel Prize in Physics, which was awarded for the discovery of macroscopic quantum mechanical tunneling and energy quantization in an electric circuit. So, again, in a similar manner, sir will simplify the matter and will discuss with us. Over to you, sir.
Thank you very much. So first of all, I'd like to thank all of you for being here, and it's a very great effort from GUJCOST as well as ITIE. And definitely this is a very good platform because as we all know, Nobel Prize is something like, this work is extremely novel, right? and it's extremely transformative. That means it will really change the world in coming years. So today I'll be going to talk about this 2025 Nobel Prize in Physics, which is mostly about quantum. Okay. Gujarati मेरे को उतना नहीं आता. Okay, so it will be mostly in English and Hindi. Physics, I feel like most of you might not like. Physics में बहुत maths है, right? But physics is very fun, right? Because you see the phone that you have in your hand, laptop, cameras, right? Everything is run by physics and electronics, right? And quantum is a very big part of it. We'll be going to learn about it. So this 2025, so this next slide is not coming. One sec. Okay, little bit time. Okay, perfect. Thank you. So 2025 Nobel Prize in Physics went to Professor John Clark from University of California, US, Professor Michael H. DeVore from Yale University, and Professor John A. Martinez from University of California. So what this is all about, there is a very niche phenomena in quantum known as quantum tunneling. Okay, so in a classical world, it's impossible to move from left hand side to right hand side. So only one way to move is that you'll have to climb up the hill, right? So that's as per classical, right? But in quantum, there is a very finite way that particles can tunnel through. जैसे कि मान लो कि एक barrier है, उसके अंदर से ही particles can pass through. इसको बोलता है tunneling effect, okay? And this not classical particles can do, this only quantum particles can do. ठीक है? क्योंकि quantum में क्या होता है कि particle भी होता है और wave भी होता है. Okay, so this thing, like quantum objects act as both particles and waves. Particles में क्या होता है कि particles if you throw on a wall, right, it will bounce back. Okay. Wave में क्या होता है कि एक finite chance होता है कि वो wall के through भी जा सकता है, क्योंकि wave में क्या होता है, particle will be here, particle will be here, particle will be here, right? Wave means there is a finite probability that particle is present in all the portion of the wave. ठीक है? Particle में क्या होता है कि only the particle is present at one particular point. So wave में there is a finite probability that particle can exist in various possibility of states at that same point of time. तो इसमें क्या होता है, quantum tunneling, the first basic thing is that the barrier thickness should not be very high, it should be very thin. ठीक है ना? जैसे कि मान लो कि ये जो thickness है, right, it should not be in nanometer scale, it should be very very thin. Okay, first point. Second point is that the quantum particle के पास enough energy होना चाहिए. ऐसा नहीं कि if the particle is very weak in energy, it cannot quantum tunnel through. So that means the energy should be quantized. There should be some specific states of energy that if those particles have, they can only tunnel through. ठीक है? और third point है कि which I have talked about, quantum space में particle और wave coexist at the same point of time. Okay, तो wave can tunnel through, particle cannot tunnel through. So जब भी एक barrier दिखता है quantum को, so it acts like a wave and it can tunnel through it, provided it's having enough energy and provided the barrier thickness is very thin. Okay, and the last part that I have already talked about, these energy systems are very discrete. That means all energies cannot help particle to tunnel through. So with that, one more concept that I'll be going to talk about right now. As you can see from this left hand side, suppose एक wave जा रहा है, ठीक है, और बीच में there is a barrier, right? So suppose that wave is going through, there's a very finite probability that some part of the wave will be going to tunnel through or quantum tunnel through that barrier. But उसके बाद क्या हुआ, the amplitude of the wave will not be the same as the beginning part. As you can see, right, amplitude meaning from the center how much it can vibrate, right? Left hand side it's not the same as right hand side. Amplitude will be definitely going to change, but the particle has tunneled through. So this phenomena is known as quantum tunneling effect. So the next thing that I'll be going to talk about is what Nobel laureates have found out also. This quantum tunneling can only occur at certain electronic energy levels only. That means मान लो कि वहाँ पे एक staircase जैसा है, ठीक है ना? वो staircase में हर एक stair में मान लो कि those are the energy states. So in those energy states only particle can quantum tunnel through. And from this figure you can see कि top वाला stair में जो particle है that's having the most energy maximum, right? तो उसके लिए barrier thickness is less, right? So what does this figure means is that if the energy of the particle is more, the barrier thickness that that particle will be going to experience will be less, and there is a very finite probability that the particle can quantum tunnel through this barrier or through this quantum barrier. So one more thing that all of us should know about this very niche concept known as superconductivity. Okay, so what does this mean? This means that when you are cooling down certain materials, they will be going to conduct electric current at zero resistance. Okay, that means if you charge a superconducting coil, that current will be going to flow through that coil throughout its lifetime. Okay, so how does this affect? In the first picture you can see in a normal conductor there are a lot amount of electrons. Okay, na? So these electrons will be going to talk to each other, scatter, and that promotes this activity known as resistance, right? So when resistance is more and you flow current, the material will get heated up. Okay, so that's how a normal material or normal conductor behaves like. In the second case, you can see when that material is being cooled down. Okay, so when that material is in the superconducting state, उसमें क्या होता है? उसमें there is a very important phenomena that happens which leads to the formation of Cooper pairs. इसमें क्या होता है कि इलेक्ट्रॉन दोस्त बन जाता है. Conductor में electrons are not those, they are rivals. They will be going to scatter. Okay, superconductor में electron दोस्त बन जाता है और वो pair को बोलता है Cooper pair. Okay, so now how does this help? So all of these Cooper pairs in a superconducting material are friends. All of them will be going to act like wave, right? और अगर मान लो कि if we break the superconducting material, if you see in this figure 3, since it's a wave, right? So that wave can tunnel through this quantum barrier. So now, you know, like this quantum tunneling effect was already discovered long time back. Okay, so there was nothing new about this. But what's very new in 2025 discovery, okay, was that they have proved that it's a macroscopic effect. So what people have proved long time back, that only one electron can tunnel through, right? Right now what they have proved that a huge bunch of Cooper pairs can tunnel through. That means it's not a very microscopic event, it's a macroscopic or bulk event. Okay, so what they do is that when they increased current, if you can see in this lower figure, when they increase current and they can measure a finite voltage in the potential barrier, which means that things are actually moving through the barrier in a macroscopic amount. So this was done for the very first time. Now again, as all of we know, right, I mean the experiments what those Nobel laureates did, right, were not recent experiments. These experiments they have done in 1984-85, right? So this whole span of time is spent to validate those experiments. Nobel Prize is only given to those folks, you know, like whose experiments are validated multiple number of times, and it's guaranteed that it will be going to change or transform our world, right? So from 1984 to 85 till 2025, all those experiments were being validated at several research labs and research institutions, and finally they got the Nobel Prize in 2025. Now, this quantum tunneling effect is something which we can also see in our real life also. So here in this video, video plays. So this is a very simple device that we have made in our lab, which is known as QRNG, which is quantum random number generator. So I'll be just going to pause this video for a moment. So before that, let me ask you, so do you think your passwords are protected? Maybe not, right? Okay, so at this point of time it might be protected, right? But when quantum world will be there, a quantum computer can hack your password within milliseconds. Okay, why? Because it can process information at a very faster rate than we can even imagine, right? So what does this QRNG device does is that it will be going to do this quantum tunneling effect, and this quantum tunneling effect is also known as a purely random effect. That means we cannot predict. No one cannot predict when tunneling will occur, right? And when tunneling will be going to occur, we'll be going to generate bits as zeros and ones, right? And we'll be going to convert those bits into a unique QR code or into a unique password. Okay, so we'll be going to patent this one pretty soon. Before that, I'll be just going to show how this works is that, so once when we turn on this device, it will be going to show you. So when you see the number 1, that means the quantum tunneling is happening. Okay. When you see the number 0, that means quantum tunneling is not happening, right? Now this sequence of ones and zeros we cannot predict. Okay, so it's a purely random event. And by utilizing these 1, 0, 0, 1s, all of these things, we can generate a unique QR code and a unique QR password for all of you. And this password will be extremely unique. So this password has not even been generated anywhere in the whole world in any lifetime. Okay, so this is known as a purely quantum random number generator device. That means, this tunneling effect is an actual thing. This tunneling effect we can even demonstrate and we can even do in research labs. Now, what's the impact of this 2025 physics Nobel Prize? The first thing is that it forms a very basis of quantum computing, wherein they have actually proved that this quantum tunneling effect is not only for single electrons. It can be in macroscopic amount, or a huge amount of wave packets can effectively tunnel through. Because if it was only for single electrons, making those devices will be extremely costly, very, very costly, right? But if it's bunch of electrons, then making those devices will be extremely inexpensive. That's the first thing. Second thing is that this discovery will be going to advance quantum technologies in all of the aspects, in quantum sensing, communication, and everything that you can even imagine of. And definitely all of these discoveries will be going to give rise to very basic and applied research work in quantum field. So the key takeaway points from today's talk will be that 2025 Physics Nobel has bridged the gap between classical and quantum world, first thing. The second one is that they have been very decisive to prove that this quantum tunneling effect has evolved from microscopic to macroscopic events, second thing. And the third thing is that this quantum tunneling is a purely random event. That means we cannot predict. So this event can be utilized to generate unique passwords and unique passcodes. And the fourth one will be that when you are trying to cool down superconducting material, the electrons will not be enemies. Electrons will be friends. Okay, and that pair is known as Cooper pairs. So this formation of Cooper pairs helped them to make this discovery of 2025 Nobel Prize in Physics. And the fourth one will be quantum particles act as both wave and particles, so which helps them to tunnel through barriers which normal classical particles cannot tunnel through. Okay, in only quantum world tunneling can happen because that quantum object is acting both as a wave and as a particle. And the last one is quantum tunneling can only occur when you are giving certain amount of energy to that particles. At all energy levels it cannot tunnel. That means energies are discrete or quantized. So all of these things are being told by 2025 Nobel Prize in Physics. And with that, I'd like to thank all of you for being here, and thanks for being patient. Thank you.
Thank you so much, sir. I would like to invite Dr. Poonam Bhargav ma'am to please felicitate our expert, Dr. Anak Bhomik sir, with a memento. Thank you, sir. Now this forum is open for interaction with our subject experts. So if anybody has any question, our experts are here to answer to the questions. Anyone? ठीक है sir. Now I would request the IT team to live stream the Nobel investiture ceremony.
Highness, Princess Ingrid Alexandra, and then His Majesty's aide-de-camp.
Of this year's Nobel Peace Prize, the question has been posed: does democracy really lead to peace? The research findings are crystal clear, and the answer is yes. Not because democracy is perfect, but because the mechanisms of democracy make war less likely. Democracies are equipped with safety valves, free media, power-sharing structures, independent courts, civil society organizations, and elections that make it possible to change leadership without violence. In this political environment, differing options are not a threat to be put down, but an advantage. In a democracy, a leader who ignores facts can be replaced in the next election. In an authoritarian regime, the leader stays in power and replaces all who tell uncomfortable truths. Loyalty takes the place of reality, and dangerous decisions are taken in the dark. War is always costly, but in authoritarian regimes, it is not the leaders who pay the highest price. This is why democracy almost never go to war with each other, as authoritarian states are more prone to do. Nicolas Maduro's rule in Venezuela shows why. Conflicts are resolved with brute force, not negotiation. The result is a society where millions are forced into silence, with consequences that do not stop at the border. Instability, violence, and systematic destruction of the country's institutions have affected the entire region, and a neighboring country has been threatened with military invasion. Venezuela demonstrates with painful clarity that authoritarian rule both destroys a society from within and spreads instability abroad. Democracy is obviously no guarantee of peace, but it is the most effective system we have to prevent violence and conflict. This line of reasoning often prompts a well-known counter-argument, that democracy itself causes unrest and conflict, that demanding freedom is dangerous. This is an old claim. Authoritarian leaders have used it for generations to defend their positions of power. Today, they supercharge the argument with disinformation and propaganda, two of their essential weapons. Ladies and gentlemen, as citizens of a democracy, we have a duty to be critical of information sources. Alarm bells should ring when the views we express are identical to those disseminated by one of the world's most manipulative disinformation systems. For in that case, we are not just spreading information, we are spreading the strategic propaganda of a dictator. What are we all to think when we read that is the Venezuelan opposition that is threatening the country with war, that the democratic movement desire an invasion, when the narrative is turned upside down and when the victims are branded as aggressors. This is a version of reality that the Maduro regime tells the world, that it is the guarantor of peace. But peace based on fear, silence, and torture is no peace. It is submission depicted as stability. No, the source of the violence is not the democracy activists. It is those at the top who refuse to cede power. It was not Nelson Mandela who made South Africa violent, but the apartheid regime's crackdown on demands for equality. Opposition groups did not start the imprisonments in Belarus, the executions in Iran, or the persecution in Venezuela. The violence comes from authoritarian regimes as they lash out against popular calls for change. Peace and democracy cannot be separated without draining both of meaning. Lasting peace depends on the rule of law, political participation, and respect for human dignity. Before we can discuss political disagreements, we must establish some form of democracy. Without it, there is no meaningful distinction between right and left, no way to legitimately disagree, no genuine politics. Democracy is not an expendable luxury. It is not an ornament to be put on a shelf. Democracy is hard work. It is action and negotiation. It is a living obligation. The instruments of democracy are the instruments of peace. We gather here today, therefore, to defend something far more important than either side of a political or ideological divide. We gather to defend democracy itself, the very foundation on which lasting peace rests. When people refuse to surrender democracy, they refuse to surrender peace. One who understands this is Maria Corina Machado. As a founder of Sumate, an organization devoted to building democracy, Ms. Machado stepped forward to advocate free and fair elections more than 2 decades ago. As she herself put it, it was a choice of ballots over bullets. In political office and in her service to organizations, Ms. Machado has spoken out for judicial independence, human rights, and popular representation. She has spent years working for the freedom of the Venezuelan people. The presidential election of 2024 was a key factor in the selection of this year's Peace Prize. Ms. Machado was the opposition presidential candidate and the country's unifying voice of hope. When the regime blocked her candidacy, the movement might have collapsed, but through her support behind Edmundo González Urrutia and the opposition stayed together. The opposition found common ground in the demand for free elections and representative government. This is the very foundation of democracy, our shared willingness to defend the principle of popular rule, even if you disagree on policy. At a time when democracy is under threat around the world, it is more important than ever to defend this common ground. Hundreds of thousands of volunteers mobilized across political divides. They were trained as election observers and used technology in new ways to document each step of the election. Up to 1 million people stood watch over polling stations around the country. They uploaded vote tallies, photographed records, and secured copies before the regime could destroy them. They defended this documentation with their lives, then made sure the world learned the result of the election. This was grassroots mobilization, unlike any that Venezuelan and probably the world had ever seen. Ordinary citizens from all walks of life carrying out systematic, high-tech documentary work in an atmosphere of threats, surveillance, and violence. The efforts of this democracy movement, both before and after the election, were innovative and brave, peaceful and democratic. The opposition received international support when its leaders publicized the vote counts that were collected from the country's election districts, showing that the opposition had won by a clear margin. But the regime denied it all. It falsified the election result and clung to power violently. For the past year, Ms. Machado has had to live in hiding. Despite serious threats, she has remained in the country, an inspiration to millions. She is receiving the Nobel Peace Prize for 2025 for her tireless work promoting democratic rights of the people of Venezuela and for her struggle to achieve a peaceful and just transition from dictatorship to democracy. For a long, long time, the opposition in Venezuela has relied on democracy's toolbox to wage its peaceful civilian campaign. Over the years, Ms. Machado and her allies have had to adapt and change tactics. They've applied almost every democratic tool, from election boycotts when the system was too rotten, to participation when small openings in the process made it possible. They've tried dialogue, organization, mobilization, and extensive election documentation. Ms. Machado has appealed for international attention, support, and pressure, not for an invasion of Venezuela. She has urged people to stand up for their rights using peaceful, democratic means. Peace research shows it clearly. Widespread, non-violent mobilization is among the most effective methods of achieving political change in a dictatorship. When a population mobilizes and the international community exerts strong pressure and the security forces refrain from using violence against the population, a tipping point may arrive. As the leader of the democratic movement in Venezuela, Maria Corina Machado is one of the most extraordinary examples of civilian courage in recent Latin American history. This year's Nobel Peace Prize fulfills all three criteria stated in Alfred Nobel's will. First, the Venezuelan opposition has united political movements, civil organizations, and ordinary citizens in a pursuit of one goal: the restoration of democracy, pulling together diverse groups that previously opposed one another is the modern equivalent of what Alfred Nobel called holding peace congresses. Second, Venezuela's democracy movement has opposed the regime's militarization of society. The regime has armed thousands of groups, authorized paramilitary bands to commit abuses, and invited foreign military forces into the country, thereby accelerating the militarization. By documenting abuses and demanding accountability, the opposition seeks to strengthen civilian democratic authority and roll back the influence of weapons. This deprives criminals and regime-friendly militias of their arms and autonomy, and satisfies Nobel's criterion of seeking peace through disarmament. Third, true fraternity or fellowship, the kind Alfred Nobel envisaged, requires democracy. Only when people are able to choose their leaders and speak without fear can peace take root, whether inside a society or between countries. Democracy is the highest form of fellowship and the surest way to lasting peace. Therefore, here today, in this hall, with all the gravity that attends the Nobel Peace Prize and this annual ceremony, we will say what authoritarian's leader fear most. Your power is not permanent. Your violence will not prevail over people who rise and resist. Mr. Maduro, accept the election result and step down. Lay the foundation lay the foundation for a peaceful transition to democracy, because that is the will of the Venezuelan people. Maria Corina Machado and the Venezuelan opposition have lit a flame that no torture, no lie, and no fear can extinguish. When the history of our time is written, it won't be the names of the authoritarian rulers that stand out, but the names of those who dared resist, those who stood tall in the face of danger, those who kept going when others gave up. Carl von Ossietzky, Andrei Sakharov, Nelson Mandela. In its long history, the Norwegian Nobel Committee has honored brave women and men who have stood up against repression, who have carried the hope of freedom in prison cells, in the streets, and in public squares, and shown by these actions that resistance can change the world. Today, we honor Maria Corina Machado. We pay tribute as well to all who wait in the dark, all who have been arrested and tortured or disappeared, all who continue to hope, all those in Caracas and other cities of Venezuela who are forced to whisper the language of freedom. May they hear us now. May they realize that the world is not turning away, that freedom is drawing closer, and that Venezuela will become peaceful and democratic. Let the new age dawn. Thank you.
And after warm applause, the chair of the Nobel Committee, Jürgen Wachtner-Friednes, will call forward Anna Corina Sosa to receive the Nobel diploma and medal on behalf of her mother, Maria Corina Machado, whose chair on the podium remains empty today.
I now call upon Ms. Ana Corina Sosa Machado, the daughter of the Nobel Peace Prize laureate for 2025, to step forward to receive the diploma and the gold medal on behalf of her mother, Miss Maria Corina Machado.
And she steps forward to receive the award on behalf of her mother, who's unable to be with us in Oslo today. Many in the audience choose now to stand in ovation in recognition of the democratic movement in Venezuela. As photographers capture the moment, these pictures from this year's Peace Prize will be shared around the world. Before the Nobel lecture, we'll have some more music. Standing on the podium now is Vera Son, singer and songwriter from Oslo, Norway. We'll hear two compositions, Solbønn, or Sun Prayer, written by Julie Kvernberg, and then the traditional Nu rinder solen opp av Østerlidet, now the sun rises from the eastern slopes. With her is Martin Steinum Brun.
To see this woman there in that rally, Carmen asked her, "Why are you here?" And the jefa de calle replied, "My only son who fled to Peru asked me to be here today. He told me that if Maria Corina wins, he will return home. Tell me what I have to do. I'll do anything. That day, love defeated fear. 2 weeks later, we reached Delicias, a tiny village swallowed by Colombian guerrillas and drug traffickers, where not even a chicken can be sold without their permission. No candidate had gone there since 1978. And as the team climbed the mountain, I saw Venezuelan flags waving from every humble home. I naively asked, as if it was a national holiday that merited all the flags, and someone whispered, "No, here the flags are hidden. Bringing it out is dangerous." Today, people raise them to thank you for daring to come. You will leave, but we will remain identified. That day, entire families stood up to the armed groups that ruled their lives. And when we sang the national anthem together, sovereignty returned in a single fragile, defiant chorus. That day, courage defeated oppression. Our gatherings became intimate encounters of thousands. We embraced, we cried, we prayed. We understood our struggle was much more than electoral. It was an ethical struggle for truth, an existential struggle for life, and a spirit.
હું ઇન્વાઇટ કરીશ આ કાર્યક્રમના કોર્ડિનેટર આઈઆઈટીમાંથી ડૉક્ટર પારસ ઉચાટ સરને.
Good evening, all. First of all, it is really very surprising for me because I am going for a different purpose to GUJCOST, and I got this gift to organize this beautiful event. So, first of all, I would like to thank the Honorable Director of GUJCOST, Dr. Narottam Sahu sir, so for selecting our institute for special outreach program of Nobel Prize 2025. Secondly, I want to like to thank our Honorable Vice Chancellor sir, who gave the permission in very short notice of time, and he make agree for all this arrangements. So thank you, sir. I would like to thank all the students who has participated in this. I'd like to thank our director, Madam Prerna Madam, who gave all the support to me. Dr. Punam Bhargava Madam, and our own Pavit sir, who helped me to just arrange all the things. Thank you once again. Thank you much. Thank you very much.
થેન્ક યુ સો મચ સર. ખાસ કરીને વીસી સર અને સાહુ સર માટે પણ, કેમ કે આખા કાર્યક્રમમાં આપણી વચ્ચે સતત ઉપસ્થિત રહ્યા એમના બિઝી શેડ્યુલ વચ્ચે પણ. સો પ્લીઝ ગીવ અ હ્યુજ રાઉન્ડ ઓફ અપ્લોઝ. હવે આ પ્રોગ્રામ શેડ્યુલની જે પીડીએફ ફાઇલ છે એમાં 8:30 PM ઓનવર્ડ્સ યુ વિલ બી એબલ ટુ સી ધ સાયન્સના જે નોબેલ પ્રાઇઝ છે. આપણે પીસ પ્રાઇઝનું અહીંયા લાઈવ સ્ટ્રીમિંગ જોયું, અને હવે એ 8:30 PM ઓનવર્ડ શરૂ થશે, અને એ પહેલાં આપણે નીચે ડિનર માટે બધા જોઈન કરીશું. સો આઈ ઇન્વાઇટ ઓલ ઓફ યુ ફોર ધ ડિનર, અને એના જેવું જ લુક એન્ડ ફીલ આવે એવું વ્યવસ્થા કરવાની કોશિશ કરી છે અમારા સરના માર્ગદર્શનમાં. સો થેન્ક યુ, and join us for the dinner. Thank you. Thank you.